Hello students, in this video we are going to discuss about one more important topic in the pharmaceutics, that is the pharmaceutical calculations. And here we will be seeing about the calculations of proof spirit, isotonic solutions and alcohol dilutions, right? So first let us see about this proof spirit. So in this video particularly I'll be discussing about what actually the concept of each type of the topic, and also we will be seeing a little examples. Okay, so alcohol, it is considered as an excellent solvent because it has many applications in the pharmaceutical practice, and it is also known as an essential ingredient of many cosmetic preparations. But however, alcohol attracts the excise duty that is levied by the government. Okay, so that is whenever you are using the alcohol, the government of it has to be governed by the statutory provisions. So for calculation of these excise duties, the alcohol strength is calculated in terms of the proof spirit. Okay, so this proof spirit was officially bought in British Pharmacopoeia 1885. According to this, the London proof spirit is nothing but 12/13th part of the equal volume of distilled water at 51 degrees Fahrenheit, and it consists of a specific gravity of 0.91976 at 15.5 degrees centigrade and contains 57.1% volume by volume or 49.28% weight by weight. These are important for the competitive exams, these values, okay, of the ethyl alcohol. This is in London. However, in India, we consider 57.1% volume by volume of ethyl alcohol is the 100 of proof spirit, and in USA it is 50%. In India it is 57.1%, whereas in US it is 50%. So therefore, proof spirit, it is an aqueous solution that contains 57.1% volume by volume of the absolute alcohol. Right. So any alcoholic solution which consists of 57.1% volume by volume of alcohol, it is called as a proof spirit, and it is called as a 100% proof. Okay, it is called as a 100 proof. Any strength that is above this 57.1% volume by volume, then we call it as a overproof, and we write it like this. Okay, this is called as a overproof, and anything that is less than this concentration we call it as a underproof. This is important, degree overproof and degree underproof. So this is called as a underproof. So in India, the excise duty is calculated in terms of rupees per liter of proof alcohol. So any percentage volume by volume of alcohol can be converted into proof strength, and the vice versa also. So the technique or the procedure that we follow in order to calculate the convert into proof strength or vice versa, first you have to multiply the percentage strength of alcohol by 1.753 and then subtract 100 from the product. So if the result is positive, then we call it as a overproof, and if the result is negative, we call it as a underproof. And now you should understand why only 1.753, why not the other number? Okay, because 57.1% volume of ethyl alcohol is nothing but 100 proof. Okay, then what is the one volume of the proof? That means 100 divided by 57.1, which gives the value 1.753. That is why you have to multiply the percentage strength with 1.753 and then you have to subtract the 100 from this. Okay, right. Let us see one example. So the first one is find the strength of 95% volume by volume alcohol in terms of proof spirit. So you have the formula, that is percentage strength of alcohol multiplied by 1.753. So what is the percentage strength we got here? 95. So 95 multiplied by 1.753 minus 100. So here you will get the value as If you calculate 66.53 and this is a positive value, so you have to write the answer as 66.53 degree over proof. If you don't write these units, the answer will not be valid. Okay, so this is 66.53 degree over proof. And now we have another example. Convert 30% volume by volume alcohol into proof spirit. You may just pause the video here, do the problem yourself, and then come back to the video again and check if your answer is correct or not. So here 30 multiplied by 1.753 minus 100. So you'll get it as 52.5 minus 100, where the value is minus 47.41. So as it is a negative value, you should write it as 47.41 degree under proof. When you are writing these units, again you should not keep minus here. Okay, then it will be wrong. Okay, so you should not write the minus here. The answer will be 47.41 degree under proof. Okay, this is the answer. When you are writing it as under proof itself, we can understand that it is a negative value. Now we will see the vice versa calculation. Calculate the real strength of 30 degree over proof and 40 degree under proof. So 30 degree over proof is nothing but 100 plus 30, which gives 130. So alcohol strength is equal to 130 divided by 1.753, which gives the value 74.15% volume by volume. Again, this percentage volume by volume is important to write here. And now 40 degrees under proof. That means 100 minus 40, which we get it as 60. So alcohol strength is equal to 60 divided by 1.753, which gives the value 34.23% volume by volume. Okay, and then the next example that we have is the calculate the real strength of 70 degree over proof and 70 degree under proof. This one you just try yourself and just comment me the answers that you have got. Okay, so this is a homework for you. Right. Then coming to the isotonic solutions. This is the next one that we have in the pharmaceutical calculations about the isotonic solutions. So there will be a variety of drugs that will be administered to the human body for different therapeutic purposes. But the solutions having the same osmotic pressure, they are called as a isoosmotic, or they are also called as a isotonic. Those solutions which do not have the same osmotic pressure, they are called as a paratonic. And these paratonic, they can be either hypertonic or they can be also hypotonic. Right? So it is not always necessary that solutions which are isoosmotic should be isotonic. So if a red blood cell is in contact with a solution that has the same osmotic pressure as that of the blood plasma, the cell wall will neither swell nor shrink. So it will retain its tone, and therefore the solution is called as a isotonic. And a solution that is containing 0.9% of NaCl, we call it as isotonic. Why only this 0.9% of NaCl is called as a isotonic? Because the blood plasma, it consists of 0.88% of inorganic salts, mainly the sodium chloride. So a solution that contains 0.9% of NaCl, it is practically called as isotonic with blood plasma and is regarded as a standard. So the solution which have which consists of more than 0.9% of NaCl, they are called as hypertonic, and if they consist of less than 0.9% of NaCl, then they are called as a hypotonic. Right? right? So you are clear about the hypotonic and hypotonic. So there are two methods in order to adjust this tonicity. So that methods, they are called as a freezing point method and molecular concentration method. So first let us see the freezing point method. Here the formula is, this is the formula. The percentage weight by volume of adjusting substance needed is 0.52 minus A divided by B, where A is the freezing point of the unadjusted solution and B is the freezing point of 1% weight by volume solution of the adjusting substance. You have to remember these formulae. And the second method is based upon the molecular concentration, where the formula is percentage weight by volume of adjusting substance required is 0.03 m by n, where m is gram molecular weight of the substance and n is number of ions into which the substance is ionized. These two are the formulae that we have. Let us see one or two examples here. So the first example is, find out the proportion of procaine hydrochloride which will yield a solution that is isoosmotic with the blood plasma, and in the problem itself it will be given as what will be the freezing point. So here the freezing point of procaine hydrochloride is minus 0.122 degrees centigrade. So you can go with the first method, that is freezing point method, where the formula is 0.52 minus A divided by B. Okay, so here percentage weight by volume of procaine hydrochloride required is equal to 0.52 minus, so here what is a freezing point of the unadjusted solution. So when the freezing point is not given, we are not going to take any freezing point. So unadjusted solution is the, here we have it is the sodium chloride, right? So 0.52 minus 0 divided by freezing point of 1% weight by solution of the adjusting substance. What is the adjusting substance? That is a procaine hydrochloride. So that is 0.122, where we will get it as 4.26% weight by volume is the answer. And we have another problem. Find the concentration of sodium chloride required to make a 1% solution of boric acid isoosmotic with the blood plasma. So again it has given the freezing point of boric acid and freezing point of 1% solution of NaCl. So percentage weight by volume of NaCl required is equal to 0.52 minus 0.288 divided by 0.576, which gives the value of around 0.402% weight by volume. Right? And then the third example we have is the, find the proportion of dextrose needed to form a solution isoosmotic with blood plasma, where the molecular weight of dextrose is given, that is 180. So we can go with the molecular concentration, where the formula is 0.03 m by n. M is the gram molecular weight. You have got the gram molecular weight, and n is number of ions into which the substance is ionized. But dextrose is a non-ionizing substance. Okay, it is a non-ionizing substance. So weight, percentage weight by volume will be equal to 0.03 m. That is 0.03 into 180, which we get it as 5.4 grams per 100 ml. This is the answer. And one last problem, let us see under this isotonic solutions. Find the concentration of sodium chloride required to produce a solution isoosmotic with blood plasma, where the molecular weight of NaCl is given as 58.5. So we know that it ionizes into 2 ions. So N will be equal to 2. So W is equal to 0.03 m by N. That is 0.03 into 58.5, the molecular weight of NaCl, and it ionizes into 2 ions divided by 2, where the value will be 0.88 gram per 100 ml. This is how you will be calculating the isotonicity or amount of the substance needed to adjust the tonicity of a substance, right? And then we have the alcohol dilutions. Alcohol dilutions here is nothing but how much amount of the alcohol that you have to take, the strength, the stronger alcohol in order to prepare a certain concentration. So the formula that you have here is volume of stronger alcohol to be used is equal to volume required multiplied by percentage required divided by percentage used. Okay, so let us see one example here. Calculate the amount of 90% alcohol required to prepare 400 ml of 45% alcohol. So volume required, how much you require to prepare 400 ml? So 400 multiplied by, what is the percentage required for you here? 45%. 45 divided by using which concentration you have to do this? By using the 95%. So it gives you around 189.48 or something. So nearly equal to 190 ml. That means 190 ml of 95% alcohol is required in order to prepare 400 ml of the 45% alcohol. That last sentence you have to write. And then one more example, let us see. Calculate the volume of 95% alcohol required to prepare 250 ml of 70% alcohol. So I suggest you to just have a pause here, calculate by yourself and then get back to the video. So the volume required will be equal to 250 into 70 divided by 95, which you will get around 184.2, that is nearly equal to 184 ml, right? And then one more important method that we have is the alligation method. So this alligation method will be used when the calculation involves mixing of two similar preparations of different strength. In order to prepare a preparation of intermediate strength, this method will be used. Here in the alcohol dilutions, you have used only one strength of alcohol to provide another strength of the alcohol, but alligation method will be used when you have to prepare a certain strength which is in between the two strengths that has been given for you. For example, here let us see one example. In what proportion should a preparation containing 15% of drug to be mixed with one containing 25% of drug to prepare 20%? So they are asking you to take 25% of alcohol, 25% of drug and 15% of drug. By mixing these two, they are asking you to prepare the 20% of the drug. So here we go with the alligation method. Okay, so 25 minus 20 you will get 5, 20 minus 15 you will get 5. That means 5 parts of 25% of drug and 5 parts of 15% of drug are used in order to prepare a mixture of 20% strength. Okay, so in the same way you can also take something like, if you have 70% of the drug and 60% of the drug and you are asked to prepare 50% strength. So what you will be doing here again, 70 minus 50 it is 20, 60 minus 50 it is 10. So 10 parts of 70% drug and 20 parts of 60% drug are to be used in order to get the strength of the 50%. Okay, so this is one of the most important method that we use in order to calculate the percentages from the given two types of the percentages, right? This is very, very important, the pharmaceutical calculations. Hope you all are aware about how to calculate the different types of the things based upon the proof spirit, isotonic solutions or alcohol dilutions. Definitely in the external exams you will get either one or two. It may be in the 2 marks questions, or sometimes they may ask you some bunch of problems in the 5 marks questions as well, right? Hope you understood well. Thank you.